In this problem here, the question asks, which of the following compounds is the most acidic? And since we're in the aromaticity chapters, that's going to be the rationale behind the acidity of these compounds. So in order to do this, we have to figure out which hydrogen could, in theory, be the most acidic for each one of these molecules. So if we look at molecule 1, draw it a little bit larger here, we have a hydrogen and two hydrogens here. And we've learned that, and the best way to look at this is, hey, if we have a base, a generic base, and it comes in with somebody and grabs this, look at what it turns into. It turns into that species right there. And when we take a look at that, could that be aromatic? Because recall that the strength of the acid is dependent on the stability of its conjugate base. So when we take a look at the conjugate bases of these 5 compounds, we have to find the one that's the most stable. So if we go through this, let's just draw all the conjugate bases of each one of these compounds. So we would have this guy right here. Benzene. And then the 7-membered ring one. Didn't draw that very well, did I? Okay. So if we apply Huckel's rules to these compounds here, they're all going to be sp. Let's see. If we just do the quick rules here, they're all cyclic. Each one of these carbons right here is sp2 hybridized. So all we have to do is now just do the 4n plus 2 rule, see if that works. So 4n plus 2 equals how many pi electrons are in compound 1? There would be 4. So we can't make that statement true, but we can make this statement true. So that means this guy is anti-aromatic. If we take a look at the 5-membered ring, 4n plus 2 equals what? There's 2, 4, 5, 6. And we can make that statement true. So this one's aromatic. This guy right here, number 3, that is non-aromatic because that carbon right there is sp3 hybridized. So that is non-aromatic. Benzene right there. That's not very stable because if we look at 4n plus 2, there's 8 pi electrons in there. 4n equals 8, that would be anti-aromatic. And then this last one, how many pi electrons are there? 4n plus 2 equals, there's 2, 4, 6, 8. So that one's also anti-aromatic. So based off of that analysis, you can see that we only have one conjugate base that is aromatic. And so that would be the most stable conjugate base amongst the 5, making this guy the strongest acid.